Today we're going to talk about square roots. I know the thing says imaginary numbers, but that's really more on the other side, which is tomorrow's notes actually. What we are going to talk about first is a couple of definitions here. A square root is a number that produces a specified quantity when multiplied by itself. Okay. For example, if you don't know, the square root of 49, hopefully you know, is 7. You know, the square root of 100 is 10, and so on. Okay. A perfect square is the numbers, created when multiplying a number by itself. Okay. So, for instance, 8 squared equals 64, or 9 squared equals 81. 64 and 81 are then called perfect squares because they multiply it by itself. Imaginary numbers, that's more about tomorrow, but let's just get it out there. This is the result, and I kind of warned you yesterday that we can't square root negative numbers, only we can, because they become imaginary numbers. That is the result of square rooting negative numbers. And again, there's more on this tomorrow, but what you need to know really is that it looks like the square root of negative 16 is, well, the square root of 16 times the square root of negative 1, which is 4i. And I stands for imaginary. And really what it boils down to is I equals the square root of negative 1. Again, we'll touch more on that tomorrow. Don't let that freak you out. It's more about what we're doing today is talking about the properties of square root, and that we can take stuff that's together and break it apart, or stuff that's apart and put it together. In other words, the square root of a times the square root of b is equivalent to the square root of a times the square root of b. Okay. Similarly, when we divide, and we can say square root of a times square root of b is the same as square root of a times b. Similarly, we can break up division, and the square root of a over b is the same thing as taking the square root of a divided by the square root of b. And some of you already know this. When we had our last section, we had something like square root of 49 over 9, and that equals 7 over 3 because we can square root both of those terms. Okay. So, perfect squares. Take a second, see if you can fill in all of these here on your own. So maybe just press pause. I'm going to start filling them in, but see how many of them you can do on your own without me. Okay. So obviously check your work just to make sure you got all the right numbers down. Okay. And with that being said, what we are going to do is break all of these up. I can't find the exact square root of 20, or the exact square root of 27, or the exact square root of 50, but I can break it up into terms that I can take the square root of and terms that I cannot. And the ones that I can, I'm going to take the square root of and make them and take them out of the square root sign. And the ones that I can't, stay underneath. Okay? For instance, if I look at square root of 20, okay? Move this up a little bit here. Square root of 20 can be broken into the square root of 4 times 5. Now, based on what we set up here, we can break that down into the square root of 4 times the square root of 5. And hopefully you know that the square root of 4 is 2. What you don't know is the square root of 5. And if you can't do it, if you can't take the square root of that and you can't break it up further, so for instance, if this was an 8, I could break it up into 4 and 2 and do it again. But the fact that I can't means that I just keep that underneath. And it's that simple. Okay. What does 27 break down into? What of these numbers, so we're always looking for these perfect squares right here to be divided into each one of these terms. And 4 can't. Can 9? Yeah, 9 goes into there. So if we break it down into 9 and 3, so I'm not going to rewrite it like this. I can just break it down. I know the square root of 9 is 3. And the square root of 3 I can't do, so it stays underneath. Again, it's that simple. Okay. I'll let you guys try 3 in a minute. Let's go on to number 4. Again, let's start looking at stuff. If I take calculator and go 360 divided by 4, I get 90. That'll work, but 9 will still go into 90, so I can break it down further, which kind of brings me to 9. Can I put 9 into it? Well, yeah, 40 times, but then I can take a 4 out of there. Well, the 9 and the 4 gives me 36. Oh yeah, 36 will go into 360, of course, 10 times. So I get the square root of 36 and the square root of 10, which is 6 square roots of 10. Now let's say you didn't see that, and that you did break it down into 4 and 90. Okay, well, I could take the square root of 4, that's 2, but the square root of 90 can now get broken into the square root of 9 and the square root of 10. Okay, so let me rewrite this here like so. This is all still a multiply problem. We know the 2 comes down times the square root of 9, which is 3, square root of 10, and then this 2 times 3 gives me 6 anyway. So it doesn't matter if you pick the highest one that goes into it, you can always get there, but just make sure you keep going and to see if there's anything else left. Okay. For 224, I'm going to give you an example of that. The first thing I know is that 4 goes into it 56 times. Literally take a calculator and go 224 divided by 4, 224 divided by 9, 224 divided by 16, and so on. So I know this is square root of 4 times square root of 56 because I just divided 4 into it. This then becomes 2 square roots of 56. But I got to look back and say, does 4 go into 56, does 9 go into 56, etc. And 4 actually does go into 56 14 times. Again, using a calculator, I got that. So now I've got 2 times, well, the square root of 4, which is 2, square root of 14. Can I put a 4 into that? Nope. Can I put a 9 into that? Nope. So I get there, and that becomes 4 square roots of 14. And that is my answer. Okay. For the next one, I'm just going to give you a hint. 4 goes into it. Find the other number, and I'm going to tell you, you're going to have to break that number down even further as well. Okay. I'll let you do that in just a minute. Going on to the next one. Hopefully this stuff kind of looks familiar. But the key to all of this is to reduce first if you can. Now I can't do that in number 7. Hopefully you can just do that. I'm going to leave that one alone. For number 8, well, this one's a little bit messy because we cannot have radicals in the denominator. So when I look at this, and I think if you remember that from Algebra 1, from geometry, this will be really helpful, but this is square root of 1 over square root of 18. Well, on top, I know square root of 1 is 1. On bottom, square root of 18 breaks into 9 and 2. Okay, so I can take the square root of 9, that's 3. Square root of 2 I cannot, but I can't have radicals in the bottom. It is a math law. We cannot have that. So what do I do to get rid of it? If you don't remember, it's as simple as this. Whatever that is, you multiply it times the top and the bottom. You can have radicals on top, you just can't have them on bottom. So on top, I get square root of 2. On bottom, well, I get 3 times. Now again, these are separated, right? Up here we said we can take the ones that are together and separate them. Well, we can also take the ones that are separated and put them together. So that becomes square root of 2 times 2, which is 4. Well, we can keep going to simplify this because I know the square root of 4 is 2, and I end up with square root of 2 over 6. Okay. 9 you can do if you reduce it. I will say reduce it first. That will make it a lot easier. 10, well, that gets to be kind of a struggle, but I'll start it. Square root of 3 over square root of 20, which I'm going to break down into 4 and 5. Now again, that's square root of 3 over 2 square roots of 5, and if you look at what I did here, hopefully you can finish that problem, and I'd like you to do that in just a second. Moving along, again, if you reduce this, it will be a lot easier. And for the next one, well, I can't take the square root of 3 or the square root of 5. So let me break this down. Square root of 3 over square root of 5. And again, I can't have square root of 5 in the bottom, so what do? Whatever that number is under the radical, I just multiply the top and bottom by it. The reason I do that is because square root of 2 over 2 is 1. Square root of 5 over square root of 5 is 1. Oh, I just realized you can't see any of that, sorry. Again, I'm going to go back to this one. What I did is square root of 3 over square root of 20. I broke 20 into 4 and 5. Square root of 4 is how I got 2 here, and I still need to keep going by doing something to the top and bottom. Right here, I'm showing you kind of what you have to do, because on bottom, I will get square root of 25. On top, I'll get square root of 15. Well, I can't break 15 into 4 and anything, 9 and anything, so that just stays. But the bottom gets rid of the radical. I'd like you to try the rest. Try 3, 6, 7, 9, finish number 10 and 11. So again, 3, 6, 7, 9, 10, 11. Try those. Press pause a second. Try those. Come back and check your answers. So again, once I've taken the square root of 16, I don't want to take the square root again, even though I know I can take the square root of 4. Once I've taken the square root, it goes away to give me just 4. This one over here I broke down in 25 and 2, 5 square roots of 2. This one to 4 and 99. 99 I knew 9 could go into that, so I broke that down further. Square root of 4, square root of 9, square root of 11, and then simplified it. Over here, if you divide each one of these by 6, this makes it a heck of a lot easier because I get to there and I can just do square root of 1 over square root of 4, which becomes 1 over 2. And that's it. That's the answer. If you tried to take the square root of 24 and break it down into 4 and 6, it just got really confusing. Okay. Next, number 10, to finish this up, again, I got to just do square root of 5 to the top and bottom, kind of like what I did on 12. On top, I get square root of 15. On bottom, I get 2. This is square root of 25, which is 5, and I just simplified to square root of 15 over 10. Circle that there. This one again, I don't want to break down 50 because I know 2 goes into each one of these, so I get 2 on top and 25 on bottom, which again is square root of 2 over square root of 25, and then there's no really work involved. It's just square root of 2 over 5. That's the notes. Okay, your homework is the next 2 pages. It is through number 27, and this is a homework where we're not going to make it out of 10. It's going to be out of 27 points. At the top of this page, I would write all those in just to help you memorize those. Not necessarily memorize them, but be able to use them as you go. It's not something that's required for homework, but 1 through 27 all is, and again, we are going to count this out of 27 points. Have a good day.